Hello and welcome to ARCHLine.XP's Update Day. Today we have prepared two webinars for you. In the first one, you will see what BIM, Building Information Modeling as a methodology, is all about and how ARCHLine.XP fulfills all the requirements of a BIM software. We will show you the easiness of use, the efficiency and the complexity of the program. I recommend the webinar for those who already have a program and are interested in BIM. And for those who want to switch to BIM and are just getting familiar with BIM and ARCHLine.XP. In our second presentation, we will show you the new features of ARCHLine.XP and how we work each year to make the best software for our users. There will be a short break between the two presentations, so stay tuned until the end. And now, let's get started. Welcome! Today we are exploring ARCHLine.XP, a powerful BIM software for building design. First, let's look at the user interface. It's designed to be simple and direct, making it easy for you to get started. Setting up a project is quick and convenient. You can manage all your work views effortlessly. Accessing properties is easy. You can edit them on the go, keeping your project up to date. ARCHLine.XP covers all your modeling needs. Architecture, map systems, and interior design are all included. It embraces integrated design, allowing you to combine results from different disciplines seamlessly. And it includes a rich set of CAD tools. You can work in both 2D and 3D, all within the BIM environment. Layers are handled just like in AutoCAD. ARCHLine.XP combines the power of 2D drafting, 3D modeling, survey work, point clouds, BIM and map design, all in one project. It includes an integrated rendering engine, which means that without external tools, it is possible to create excellent photorealistic images. The quality is top-notch, handling many technologies such as ray tracing, PBR materials, HDRI backgrounds. Section and elevation views can be created in two ways: raster graphic image and vector drawing. Raster graphics are more efficient and versatile, but vector drawing is more accurate. Plot layout in ARCHLine.XP is a documentation view where you can place multiple drawings such as floor plans, sections, elevations, callouts, 3D views, images, title books, photos and photorealistic images. ARCHLine.XP is a parametric BIM software. That means that the program gives you a central model from which all calculations, estimates, quantity takeoffs, sections, elevations are originated. Instead of lines, you work with walls, doors, windows, roofs and so on, all equipped with their relevant properties. The software organizes the project into views, in which the model is displayed in different appearances. Each view has specific graphic settings, such as the scale of detail, visual effects, and other options that help create a quality document that communicates the project through visual representation. The objects that I click in the section are the same everywhere, and how modification operations in one or another view are reflected in all of them. For example, if I change the position or size of a door in the section view, the other views automatically follow the change. The project includes the complete description of the building and all the information needed to display the floor plans of the building and the 3D model. The software is parametric. It thinks in objects. These are, for example, the properties of a wall. When you save the project, all views of the building, such as floor plan, elevations, sections, perspective views, are saved in one file. This project file contains all the information: including the textures and settings. Within the project, the floor plan of the building, the different views, the layouts are in a dynamic relationship with each other. You can easily place the drawing that make up a project together on a layout and print them together. In this example, you can display rooms in different colors according to their various parameters. Managing the project is simple, easy to move from one computer to another one because you only need to copy one file. ARCHLine.XP is a complete software for architectural design. The fact that it natively integrates the operating logic of a normal CAD and it's compatible with CAD formats makes it suitable to be inserted immediately into an architectural workflow. I import the file and then an assistant helps me interpret the scale, especially the graphic units of AutoCAD will be updated to the metric units of ARCHLine.XP. It is then possible to filter the drawing and thus fully manage the layers, with the option of turning elements on and off. The drawing can be further cleaned with the filters, where an element type can be turned off. Now I can start the BIM conversion. Click near the start and end points of the wall, then on the other side of the wall. Then the wall appears in the 3D view. Repeat it for all the walls in the drawing. I do the same for the doors and windows by specifying 2 points on the wall that define their width. Similarly, curtain walls can be easily created by specifying 2 points on the wall. In the next step, I unify the material of the walls with a single selection. Now let's see a system of automatic generation of 3D from 2D CAD file. This intelligent tool interprets 2D drawing and transforms it into a 3D model, speeding up the design process and giving designers more time for creative work. The algorithm reviews the drawing and analyzes it, taking into account the specified wall and opening limits. During the review, it filters out unnecessary content and looks for those drawing examples that can be set with high certainty to represent walls, doors, and windows. These are transformed into real architectural elements in the next step. You can quickly create a slab that follows the contours of building walls. Draw a bounding box around the walls surrounding the slab area. Press Enter to create the slab. Then you can create identical elements on multiple floors in one step. This is useful for a repeating floor plan. In this video, we will show you how to get started working with walls in ARCHLine.XP. When I draw a wall, I can specify its length by typing the value or by clicking on the drawing. After completing the first wall, I can go immediately into a second wall and so on. The walls are automatically connected. When editing a wall, I can use the grips to adjust the length of another wall. When I select the walls, I have the properties, and if I want to unify the materials of the two sides, I can activate it or use different materials. Let's use a different wall style to draw the interior walls. There is the offset command, which specifies the distance between two walls. I select the two walls and I can type the new distance like 3800 mm and so on. about wall profiling. This is just a simple basic wall, but sometimes you need to change the shape, for example to separate two apartments' balcony. I select the wall and edit the profile. The profile is based on the drawing, where you can use the floor plan tools to create the new shape in one or more steps. The layered structure of the walls, although it seems very simple, is vital in coordinating the connections and any subsequent modifications. The structure of the wall can consist of several layers of different materials and thicknesses. Here we have just a basic floor, and let's draw a slab around the outside walls. Let's change the wall structure to a more complex one. The wall patterns determine the floor plan appearance. The wall patterns change when you are switching between coarse, medium, and fine detail levels. Drawing the sections allows me to coordinate the connection between the building structures. The section view cuts through the model. I can draw it on a floor plan. Many projects, such as renovations, take place in stages, each representing a period in the life of the project. Design phases can be separated from each other, and individual stages of the design process can be presented using phase filters. ARCHLine.XP tracks the construction of demolition phase of building elements in full documentation, including 3D views, sections, elevations, and consignation. If you demolish an element, it is marked as demolished in all views. Comparing differences between phases. The purpose of this command is to make the distinction between existing and new work clearer. Based on the parameters that can be set in the comparison window, displays the program the corresponding buildings, levels, phases, and display modes. The resulting drawing is treated as a group that is placed in a new view. The next thing I want to show you is how to make post-insulation of existing walls. Insulation of external walls reduces heat loss and improves the appearance of the building. If you only need to add one layer, copy an existing wall layer. Switch to the new construction state and change the thickness and pattern of the new layer. With the help of the phases, the existing and new wall structure of the building can be managed at the same time. From concept to spaces and zones. The software is designed to support professionals through several phases of the design workflow, from the first survey to the conceptual shape modeling, or from the first client contact. It helps us with a range of tools that combine freedom of design with the respect for local building regulations. Let's see it in action in the first quick modeling with the flexible offset command. The door tool allows the door to be placed precisely in walls and modified if needed. Doors are hosted components to wall. After selecting the relevant door type, you can specify its location on the wall. ARCHLine.XP automatically cuts the opening and places the door. The door is attached to the wall, so it's placed on the wall layer. Now I draw your attention to the Room tool, which gives you the areas, surfaces calculated according to the standards with the properties display. The room stamps are updated in the search for architectural requirements, for example managing special features such as the illumination ratio and norm-based area calculations. Let's look at the special case of the attic. The software also recognizes the minimum height, such as 1.9 meter room height. If we then move on to a more advanced phase, such as performance analysis or cost assessment, all the way to management details, we can be sure that the model database of all the informations is managed by the software in an organized and accessible way. Zones consist of one or more spaces that are governed by a common environment, such as ownership, heating, or air conditioning systems, and so on. You can create zones to specify spaces that share common environmental or system requirements. So, let's see a guide to creating a BIM model from point cloud data using ARCHLine.XP. Using point cloud data to create accurate floor plans is a multi-step process. I show you how to accomplish the complex task using ARCHLine.XP. The first step is to set up the building model levels. I find the elevation lines of the building levels and adjust the levels to the measured values. I reduce the size of the point cloud using the Filter Horizontal Planes command to display only the part of the point cloud needed to create the floor plan. I sync the floor plan and create the walls based on the point cloud data. I will add the doors and windows to the building. I use the floor plan and then the frontal view to give the exact dimensions. Next comes the roof. Using drawing tools, I measure the angle of the roof. Along the created walls, I make the roof in one step. Then I set the final height of the roof. I create the building decorations and details. The result will be a beautiful model of a small palace. That's how easy it is to use point clouds. With the ARCHLine.XP site tools, you can locate your project exactly on the planet using address or GPS coordinates. I can generate a terrain for any location that has accurate site data and accurately mapped satellite imagery on topography model. I can import terrain model and have the terrain exactly located using GPS coordinates. Terrain properties include the 3D display mode. The display can be done with triangles, contour lines, and a grid. I can import satellite view as raster image. You can import image data into the floor plan view of the ARCHLine.XP project, which can also be displayed in the 3D view. About modeling. 3D site modeling covers all elements added to the building structure. The site plan consists of topography lines, roads, zones, and the building plateau. Site model is complete, it can be coordinated with the building model. The site and the building can be precisely aligned by specifying the elevation above sea level. Terrain has its specific tools for modeling roads by tracing the road path. The program cuts the road into the terrain, or completes and fills into the missing areas according to the road height. A plateau is required when topography is added to the 3D model because it cuts through the terrain where a floor is not able to. In this part of the video, I show you how to work on an existing building in ARCHLine.XP. ARCHLine.XP has two features that allows you to design a building structure in multiple phases and document it later. The first is phasing that is native in the floor plan design. In fact, among the properties, there is a phase property thanks to which I can adjust the visibility of the element and also the recoloring or graphic overwriting. Let's see in this example how this applies to walls and wall layers. The case in question is the addition of an insulating coating. Any elements can be set for demolition with modification command. The design phases can be tracked in full documentation, so 3D views, sections, elevations, and consignation lists follow the status of the current phase. Drawing comparison tool allows you to overlap two drawings, returning a separate 2D drawing for documentation purposes. It consists of lines and fills, which are fully customizable in their style. With this function, the program allows you to compare different faces. If you change the plan, you can also update the comparison drawing with the Update Comparison command. Now we will create tiling in two ways, in 2D on the layout and also in 3D by activating the floor plan. We select the wall on which we want to create the tiling. In this case, we get the layout of the wall, which we place on the floor plan. First, we specify the area we want to cover. Now we have to choose the color of the grout. The floor space has been completed. Place the tiles on it. We select the tile first. I specify the height and width with 80 by 80 cm. The grout is taken at 1 mm. Now we will be working in 3D. But first we create a new tiling style. First select the type of the cover. From the built-in patterns, I choose the ribbon pattern. I will set up the materials. I adjust the thickness of the grout and the size of the tile, which will be 30 by 10 cm. I set up a random rotation of the tiles. We need to specify the height. We are ready with the first line. The next line will be a gold strip. From the rectangular patterns, we look for the gold in the library. The height of the cover will be 1 cm. In the next row, we cover with the same green tile, but not in a herringbone, but simply by placing the card next to each other. The height of the cover should be 20 cm. We insert other two rows. This created the tiling pattern. It is recommended to save our work as a tiling style. We switch to 3D view. We will apply the created tiling style to multiply walls. In the next step, the back of the shower wall is tiled. In the pop-up Mosaic Tiling dialog box, you can select the different tiles that make up our mosaic pattern. A maximum of 4 and a minimum of 2 tiles can be used as a mosaic pattern. Here we select 4 tiles for the mosaic: green, dark green, light green and gold. We adjust the size. For the other 3 tiles, you can specify how many times the tiles will be used, so you can use tiles of different sizes and proportions in the mosaic. The floor is covered by marble. Place the tiles on the floor, specifying the starting point and direction of the tiling. The slab under the tub is also covered by repeating the previous steps. We start with the side of the slab. Here, when specifying the starting point of the tiling, make sure that the joints run with the previous tiling. We even cover the top of the slab. Here we also fit the joint. We are done with the tiling. Now we are going to create a wall view. Activate the floor plan. Choose Documentation, then select Single Wall View, click on the wall. Pull out the arrow to define how deep your wall view should be. The wall view is dimensioned and scalable. Now create an Excel list of the tiles. In the list we get what kind of tiles we placed in the project, what is the size of the tiles, how many square meters are needed from the different styles. Now let's look at the photorealistic image. For system engineers, all MEP components require connectors. The connectors contain all the intelligence necessary to participate in a system topology. For designers, knowing how to add and remove connectors to objects can be useful to connect it, for example, a wash basin model to a plumbing system. In this example, I'm working with an automatic connection to join pipes belonging to the same hot water or cold water system. The software provides an option for routing. Routing is an algorithm that the software calculates to automatically generate the connection between two connectors of MEP objects having the same system. Selecting the destination object, the software will propose the choice of connectors of the same system to connect to. The optimal path is calculated by the software, but can later be modified by editing. In this example, we are working on the architectural part of the complex project, and we need the MEP models to be closely aligned with the architectural model. The purpose of the MEP coordination process is to ensure that the architectural design of the building does not interfere with the layout of mechanical, electrical, plumbing, or fire protection system. MEP coordination is a critical step in the BIM process. It allows potential problems to be identified before the construction begins. MEP coordination refers to the spatial coordination of all building services: heating, ventilation, air condition, plumbing, and electrical system, and the building elements such as walls, columns, beams, and floors. Data transfer between BIM programs is possible using the IFC format. We import the BIM plans as an external reference for the building model in several steps. The 3D view shows all MEP services within the architectural and structural constraints of the building. Using the Walk tool, you can navigate through a model as if you were walking through it. To walk through the model, drag the eye marker on the direction in which you want to move. Now let's speak about collision detection and resolution. At this stage of the process, the MEP connector can look at the 3D model and evaluate any clashes or collisions between the architectural elements and the planned MEP system. Any inconsistencies can be detected. Once the 3D model has gone through the clash detection test process, MEP coordination drawings can then be prepared to show everyone involved on the project how the mechanical, engineering, plumbing, and fire protection system will work together in the same space. Thank you for attending our first presentation. We will now take a short break, and then we will continue with the latest news of ARCHLine.XP.
Hi everyone, my name is Enikő and today I'm going to show you the new features of ARCHLine.XP. Let's get started. Did you know that you can automatically create a 3D BIM model of your project starting from a photo of the 2D plan of the existing building? Import a picture of the floor plan into the project and place the automatically created vectorized version of the image. You can see that the group consists of lines and arcs. Scale the group with a known distance and check the result by measuring it. With the blueprint command, auto-create the walls and openings with the specified limits, for example minimum and maximum wall thickness. The 2D floor plan and the 3D model are instantly created. Check for minor issues and correct them where needed. Add the slab to the floor. Select the 3D model and copy it to the other floors. It's so easy to create a multi-story building with the new blueprint command. The dashboard is a clear collection of the most frequently used commands related to the given view, which can be supplemented with your own set of commands. The dashboard displays dedicated commands for each view. Activate the floor you want to work on with one click, change the layer visibility, or add your most frequently used commands to it. When the 3D view is active, you can activate the saved perspective views or click on the predefined axonometric views. Change the visual style with one click, activate shadows and set the date and time with sliders. You can easily start renderings too. ARCHLine.XP will use the default settings. In the section and elevation views, you don't need to enter the properties dialog. Now you can change the most important settings directly from the dashboard. You can add drawings to the plot layout with one click and start the printing process when the project is finished. Import a door or window into ARCHLine.XP that was created in Revit. If the file includes different options, select the desired one. Save the door or window in the library. Place it on the floor plan and it will behave like the factory openings. Did you know that in ARCHLine.XP you can automatically create a 3D BIM model of your project starting from a DVG 2D floor plan? Import the DVG file into ARCHLine.XP, set the correct unit for the drawing and place it on the floor plan. Create a local group from the DVG drawing before the automatic BIM generation. Auto creation of the walls and openings with the specified limits, for example minimum and maximum wall thickness. The 2D floor plan and the 3D model are instantly created. Add the slab to the floor. Check for minor issues and correct them where needed. Select the 3D model and copy it to the other floors. It's so easy to create multi-story buildings with the new blueprint command. In this example, let's check the difference between spotlights and IES spotlights. The default spotlights give an unnaturalistic effect to the renderings. For more naturalistic images, you should use IES spotlights. Import a prefabricated IES spotlight source into ARCHLine.XP from your computer. The preview of the light sources will be displayed in the library. You can add as many light sources as you need for the project. When selected, you can see the light source's properties. Open the rendering dialog and activate the Use IES Light in All Spotlights command. Select the desired IES light from the list and start rendering the image. You can see the comparison that the IES lights are more sophisticated and add a realistic effect to your renderings. Let's see what's the difference between general materials and real emissive materials. When you expect the surface to emit light and in the render image it doesn't, the result will be unnaturalistic. To solve this problem, in ARCHLine.XP you can add real emissive properties to the materials. When a material is set to be real emissive, you can set the light intensity to the desired amount. Add real emissive properties to all the screens in your project and set the light intensity to the right value. When you start a render, these surfaces will look naturalistic and lifelike. In this comparison, you can see how much better the real emissive materials look in this scene. Once I have prepared the print plan sheet and found everything in order, I start printing. Go to the File menu and click on Print. At this point, the user interface changes, the design tools are moved to the background, and the print tools fill the entire screen. On the right is how the printed document will look, and on the left is the Print Options dashboard. The dashboard is divided into 4 sections. The first section shows you which printer to use and how many copies of the document you want to print. Remember that the documents will be printed using the default printer. If this is not correct, you will need to change it before printing. It is important to know that you can also set up the frequently used PDF printing here. Under the printer icon, you can see the printer settings by clicking on the properties. Currently, I want to print on A3 paper. The paper can be in portrait or landscape position. Beside the orientation of the paper, I could also choose to print the drawings in its default position or rotate it 90 degrees. I can choose between the optimal view and the most commonly used scales, or set a custom scale value. To set a custom scale, I'll select the custom print scale and enter the desired value. The dashboard allows you to view and select the entire drawing or predefined drawing sheets one by one. If I no longer need to make any changes, I check the printer once more and click on the print icon at the top of the dashboard. The control panel shows all the important settings for printing at once, so it's clear and easy to use. If I want to print multiple documents at once to a single PDF file, I can do this easily in ARCHLine.XP. In this case, I specify the name of the PDF output file. At the bottom of the drawings list, I click on the Create Print Queue button. If my PDF file contains different paper sizes, for example A1 and A3, I can specify
For more
one by
information
one to
and
have the
videos,
program
visit
print the
our
drawings
website
on different paper sizes.
ARCHLine.XP.com. Download ARCHLine.XP now.
Once I made the changes, I can press the Apply button to return to the Print Queue dialog and create the multi-page document. Powerful tools are available for organizing complex print layout documentation in ARCHLine.XP. Here are some techniques for managing individual drawing sheets in complex printing projects. In this example, the contents of 2 drawing sheets of the project have been updated and I would like to print them. I select these 2 from the list. The names of the drawing sheets are also shown when the tooltip is active. When you have a lot of drawing sheets on printing layout, it can be difficult to select them individually. Essential technique for managing a complex layout is the use of drawing sheet names. Drawing sheet names help you find the required drawing you want on a complex layout. To display drawing sheet names, use the Display Drawing Sheet Names checkbox in the print panel. Click on the drawing sheet name to select a drawing. ARCHLine.XP offers the possibility to print the document in PDF format, or you can use the print panel to print the document directly to the selected device. Another option for creating complex print design documentation is the print queue. Select the drawings that will be combined into a single PDF document. The current job list is on the top of the dialog is empty by default. When a printable task is added, it will be listed in this area. The print queue feature allows you to print selected drawings as a single PDF file. You can use the print panel to choose the paper size, orientation, color management, and other settings that suit your purpose. The print queue list is sorted by the project, which means you can easily update the PDF if the project changes. Viewports display partial or total views of the design space. After defining the area, create the plot layout and select the scale of the drawing. Place the drawing on the plot layout. You can start the command from the dashboard or the ribbon bar. You can crop, scale and change the orientation either on the plot layout or in the original design area. Each layout viewport displays a view of the design space, for example floor plan, section, elevation, 3D views with the scale and orientation that you specify. Drag and drop any views from the project navigator. Revision Cloud is a cloud-shaped object. It allows you to easily highlight changes you are about to make on the drawing. In the revision style settings, you can set general settings for revision clouds, including arc lengths. When you add the revision cloud to a view, ARCHLine.XP assigns the first revision to the revision cloud by default. You can assign a different revision to the revision cloud later. You can assign a revision to each revision cloud, or you can assign the same revision to multiple revision clouds. I create revision clouds on the drawing. I place the starting point of the revision cloud contour. Then I place the opposite corner point of the revision cloud contour. I assign the revision node to the revision clouds one by one. The show reference command displays the reference number assigned to each cloud in a view. The size of the text depends on the current style setting. This can be changed later. The hide reference command hides reference numbers assigned to each cloud in a view. I can place a revision cloud in section view and print layout too. Revision schedule lists the revisions related to revision clouds in the view. Not assigned revisions are not listed. Revision schedule list placed on the floor plan can be saved to Excel worksheet. The ARCHLine.XP Warehouse website serves as a two-way content center where you can search or share your ARCHLine.XP content, such as models, materials, profiles, and custom styles. It offers the designers a huge collection of downloadable objects and materials, while they can also upload any content, enriching the community's design palette. Objects can be downloaded in ARCHLine.XP and SketchUp formats. You can search by categories and subcategories or brands and product lines. Add real objects and materials downloaded from the ARCHLine.XP Warehouse to your project that your clients can buy from the manufacturers. In ARCHLine.XP 2024, you have the option to download materials from the Trimble 3D warehouse. Select the desired material and download it into the library. set the material properties, and add it to the surface you want to change. Import point cloud files with the .las extension. In this example, you can see the facade of a building. Rotate the point cloud to match the facade with the horizontal plane. Add the vertical filter to the point cloud so you have an unabrupted view of the facade. Now you can only see the facade of the building, nothing else is interrupting its view. Add the section to the project facing the facade and deactivate the Hide Point Cloud option to make it visible on the section. Create an image of the 3D view and place it on the floor plan. Scale the picture to the real length of the facade. Vectorize the picture and place the group on the floor plan. Now you have a vectorized image of the facade made entirely from the point cloud. Import large-size RCS point clouds into ARCHLine.XP in just 2 seconds. Point clouds are more and more available in the everyday use for architects and are reliable sources of the existing buildings of the projects. Add filters to the point cloud to display only the necessary parts of the building. You can add several filters to the point cloud to meet all your needs. You can easily switch between different filters, or you can deactivate them with one click. The recap file format is a collection of several RCS point clouds merged into one file. You can decide which parts of the point cloud you want to import into your project, making sure that only the necessary parts are displayed at once. As the planning process evolves, you can activate different parts of the recap point cloud, thus only the required RCS files are displayed. This is a useful method to differentiate between the included buildings or between the rooms of a building. With recap point clouds, you can make sure that the 3D view is not overcrowded with information, and you can display only those parts of the point cloud that are needed for your current plan. In this example, we are working on the architectural part of a complex project, and we need the map models to be closely aligned with the architectural model. The purpose of the map coordination process is to ensure that the architectural design of the building does not interfere with the layout of mechanical, electrical, plumbing, or fire protection systems. Map coordination is a critical step in the BIM process. It allows potential problems to be identified before construction begins. Map coordination refers to the spatial coordination of all building services: HVAC, pipework, plumbing, and electrical systems, with other disciplines making up the building structure, architectural elements, for example walls, columns, false ceilings, etc. Typical steps in the process are the following. First step, creating map model. The map design company reviews the line drawings or 3D models of the map system. Then analyzes the architectural plan in detail, making sure they are consistent with the sketches. Using map drawings, an accurate 3D model must be created using BIM. Second step. Combination of architectural 3D model and map model. Data transfer between BIM program is possible using the IFC format. Importing the map plans as an external reference for the building model in several steps: heating, air conditioning, water pipes. The 3D model of map services then allows all map services within the architectural and structural constraints of the building. It is a very important part of the process, as it lays the foundations for many construction-related plans, sections, and elevations. It can also be used to create a detailed overview of the building. Additional notes can be added to the 3D BIM model to ensure all of the measurements are clear for each discipline. Elevations and sections can also be used to explain and detail the layouts for anyone who needs access to the information. Using the Walk tool, you can navigate through a model as if you were walking through it. To walk through the model, drag the eye marker in the direction in which you want to move. Next step, collision detection and resolution. At this stage of the process, the map contractor can look at the 3D model and evaluate any clashes or collisions between the architectural elements and the planned map systems. Any inconsistencies can then be detected and solutions presented to the customer. Once the 3D model has gone through the clash detection test process, map coordination drawings can then be prepared to show everyone involved in the project how the mechanical, engineering, plumbing, and fire detection systems will work together in the same space. This is why companies often use building information modeling technology to help them streamline the map coordination process. With the Truss tool, you can add customized structures to your attic. In the Truss Properties dialog, set the material, the type of the structure, and the profile of the beams, amongst other things. Place the truss in the 3D or 2D view. Adjust the structure of the truss in the 3D view to best fit the roof of the building by changing the beam's angle, length, and position. Copy the finished truss to the required locations to finish the process. You can specify how each layer of a compound wall will finish when it's not connected to another wall. In the Properties dialog, set the desired layer endings and see how it will look in the preview window. The changes will be visible both in the floor plan and in the 3D view. Use wall layer wrapping at the sides of doors and windows. Set the layer wrapping separately on the outer and inner side of the opening. Check the result in the preview window. The changes will be visible both in the floor plan and in the 3D view. It is possible in the program to display only selected walls on other floors. This is a great help when designing multi-story buildings, as it allows you to display only certain walls on the lower or upper stories, so you don't have to display the whole floor plan. In this video, I will show you how to create windows that span across floors. Delete the extra windows and change the height of the ground floor window so it reaches the ceiling. Add more vertical dividers. Copy the properties of the window to the other windows. Find the slab on the floor plan and modify its contour so it doesn't intersect with the windows. You can now add variations to the doors and windows custom created in the Door or Window wizard. Open the Properties dialog and change the parameters to fit the new variant of the opening. Click on the Create Variant button and save the variant with a different name in the library. When you click on the opening with variants in the library, all variants of the same object will appear in the list. The room stamp can be assigned with individual room names, so you can fully personalize the room stamp applied to the floor plan. Thanks to this feature, you can add any room name to the list, so you can select not just the predefined names in the list, but custom ones too. In the Room and Area Properties dialog, you can add and delete custom room names. Add automatic hole reinforcement bars to the slab around the holes. When using a wooden structure for the slab, add reinforcement bars to it for more accurate representation. You can see in this example that by default the beams of the slab are not connected to the perpendicular beam, so we need to add reinforcement bars around the hole. In the Slab Properties dialog, activate the Beams along the holes option and set the right profile for the beams. set an offset for the reinforcement bars and save the changes. Often a texture needs to be resized and/or rotated. By default, the texture repeats in all directions. Scaling a texture means changing the physical size assigned to it. By selecting the surface, you can scale the texture from your selected points. Select a texture on a surface you want to rotate. Now we will be placing LED strips within the cabinets. We will be creating horizontally and vertically positioned LED strips and exploring how we can adjust their properties such as color, temperature and length. First, we will place LED strips with deflectors in the upper glass cabinet of the kitchen. I select the necessary unit where I will place the LED strip. Clicking on the pencil icon takes me to the cabinet dialog. Before I start placing the LED strips, I adjust the 3D representation to without fronts so I can see what I'm doing. The cabinet dialog now includes the LED lighting option where I can place the LED strips. First, I need to choose the section where I will create the LED strips. I set the orientation, which can be horizontal or vertical. Now I choose the horizontal option. Then I specify the length of the strip. If the automatic length is enabled, the LED strip will be placed along the entire width of the section. If I disable this option, I can enter a custom value. Let's set the value to 1000 mm. I create the strip with the green tick. The program places it at the bottom of the section, so I need to move it. I offset it up along the blue axis by 325 mm. I move it back by 20 mm to accommodate the deflector. I want to place the LED strip in the remaining sections with the same values. All I need to do is switch to the next section and the program automatically applies the previously entered values. Then I create the strip with the tick. I repeat this process for the other two sections. Once done, I create the deflector. I have already prepared this from a front, which has a total width of 1000 mm and a depth and height of 20 mm, so it reaches right in front of the LED strip. The deflector can be added under the Accessories menu by clicking on the blue plus sign, and I find it in my library. I move it up by 315 mm, then place it with the Create button. It's now in front of the LED strip. I proceed to the next sections, creating them with the specified offsets. I repeat the process for the remaining sections. With that, I'm done. From the list on the right, I select the appropriate LED strip, then modify its properties by clicking on the pencil icon. Here I can adjust its light intensity, dimming level, light color and color temperature using sliders. I won't make any changes now. I step back and reset the closed state of the doors in the 3D representation. I accept it with OK, and I'm finished. Let's take another look at the image to see the result. Next, I will also be placing horizontal LED strips, but this time within a bookshelf, spanning its full width. Let's switch to the next view. I've already placed some LED strips, we need to place 3 more. I aim to achieve the result shown in the image. Let's continue the work. I select the bookshelf and enter its properties. I choose the appropriate section and navigate to the LED lighting menu to select the section where I want to place the LED strip. First, I choose the right one. With automatic length enabled, the program will place the LED strip across the entire width of the section. I offset it up by 570 mm and back by 280 mm. I create it. I move on to the next section and on the left and do the same there. I move on to the next section on the left and do the same there. I repeat this for the elongated section. Here I offset the strip by 1170 mm. Now that I'm done, I accept it with OK. Now I will show you how to simultaneously adjust the color temperature of the placed LED strips. If I select the cabinet and scroll down to the bottom of the Properties menu, I can turn the lighting on and off simultaneously. If the color temperature is checked, I can modify it by clicking on the Edit button. In the last example, the LED strips will be in a vertical position. Let's switch to the next view, where I will create a wall panel on the back and I will place the LED strips behind it. First, let me show you the finished visual design. Let's get to work. I previously created a 2.75 meter high, 1.2 meter wide and a 0.6 meter wide wall panel from a front. I will use this now for making the wall decoration element. I create this under KBB menu cabinet. I will only use the back panel, so I hide all the other panels. Within the custom panel properties, I go through the list and hide the other panels. In the next step, in the default site properties, I select the pre-made wall panel. Clicking the plus button, I search for it in the library. I will use the 1.2 meter one first. Under the first menu, I set the appropriate cabinet dimensions. I don't need the legs, so I set the space for the legs to 0. The total height will be 2.75 meters and the width will be 1.2 meters. I set the depth to the same as the thickness of the back panel, so it will be 2 centimeters. With that, I'm done. I need to add more wall panel pieces. As seen in the visual design, this wall panel consists of 5 pieces. I can add these under the Accessories menu. Clicking on the blue plus sign, I find the 1.2 meter wall panel again. I accept it with OK, then create with the green tick. The program creates it where we place the first one. I offset it to the right by 1.1 meters along the red axis and back by 4 centimeters so they overlap nicely. Now that I'm done, I create the same for the left side, just offsetting in the negative direction. I need 2 more wall panels, but this time the ones with the 0.6 meters width. Again, I click the plus button and search for the 0.6 meter wall panel by clicking the blue plus sign. I move it to the right by 1.91 meters and I create it so we can see. I move it back by 8 centimeters to fit in place. I do the same for the other side. With that, the desired wall panel is done, and now we can place the LED strips on it. To do so, I select the middle panel, then go to the LED lighting menu. Now I choose the vertical direction for placement and leave the automatic length enabled. The LED strip is created in the middle of the wall panel, so I need to offset it in one direction. First, I move it to the right by 58 centimeters and back by 2 centimeters. I zoom in to ensure it's in the right position. I create another LED strip on the opposite side, which I need to offset by minus 58 centimeters. This one is done too. I still need to place 2 more LED strips. I select the green plus again, I offsetted the right by 1.86 meters and back by 6 centimeters. I create the next one, which I shift by minus 68 meters. It's nicely in place. We're done with the LED panel. Now all that's left is to place it. I want to show you that if I accept it with OK and place this panel somewhere in the floor plan, I only see the first panel that I used as the black panel. Part of the panel is in the wall, so it's not visible in the 3D. I need to go back to the editor and switch its display to top view. This way we will see all panel units. I accept with OK, then I grab it with Move command and place it precisely. Now we are done. Let's take one last look at the finished visual design. Create variants for 2D profiles to speed up your work. The profile variants are saved in the library so they can be easily retrieved later. Set the values of the new profile variants in the Edit Profile dialog and click on the Create Variant button. Save the variant with a new name into the library. You can easily switch between variants in the drop-down list of the Profiles item family or view them in the library. The shutter is the outer covering of the roller shutter. Shutter profiles can be downloaded from the ARCHLine.XP Warehouse library. The parameters of the shutter can be found in the built-in details panel of the door window properties. The shutter profile can be a simple rectangle, a downloaded profile, or a saved profile in the library. The most commonly used size is 15 x 15 cm or 18 x 15 cm. In terms of positioning, it can be either external shutter or internal shutter. The profile setting of the shutter depends on their location. Once the 3D visualization is enabled, the shutters become part of the 3D representation of the building. The vertical position of the shutters can be precisely adjusted. Its material can be aluminum or plastic. Select the material from the library to best fit your project. Road markings downloaded from the ARCHLine.XP Warehouse are placed in the project to create realistic roads. If you want to place custom road markings in your project, you can also create your own patterns and use them. Set the length and width of the pattern and it will display in the 3D view. You can later modify the area of the pattern. Add road signs to your project to make your surroundings of the building more realistic. Download road signs from ARCHLine.XP Warehouse. Hinge holes can be added to the furniture fronts, making it easier to see the position of the hinges on the fronts in the design plans and to manufacture the elements. Create a new cabinet door and add the holes for the shelf holders. In this example, we add 2 rows of holes with 5 cm distance between them. Save the cabinet front into the library. Create a new cabinet door, add the desired material and add 2 hinge holes to it. Save the cabinet front into the library. Select the cabinet you want to change and enter its properties dialog. Change both sides of the cabinet with the first cabinet door. Now the cabinet sides have holes for the shelf holders. Add the new cabinet door to the cabinet and save the settings by clicking OK. You can see in the 3D view that the cabinet sides and the front have holes in them. Import an image you want to vectorize with the blueprint command, and after placing the picture on the floor plan, it will be automatically vectorized. You can enter the group to check the lines and arcs. A bird's eye view is an elevated view of an object or location from a very steep viewing angle, creating a perspective as if the observer were a bird in flight looking downward. In the case of a room, in order to be able to see the floor area from above, it is advisable to temporarily hide the ceiling or other elements above it in the 3D view. After selecting the center of the view, the hide command is automatically activated. Move the camera for the perfect angle and set the time. By rendering this view, all the textures and materials will be included in the picture, which guarantees a high-quality image. To include the rendered image in the documentation, place the image on a plot layout. You can drag and drop it from the project navigator. In the print dialog, you can save the page separately or include it in a print queue with the whole documentation. And this brings us to the end of this video. Enjoy your work with these new amazing features. Goodbye!
So, that is the end of today's presentations. Thank you for your interest. If you are interested in buying a new ARCHLine.XP software, or you want upgrading your existing one, or if you have any questions about BIM or ARCHLine.XP, please contact your local reseller at the link below, at our website archline.xp.com. Bye!